This class, we are going to see about Z transform of some standard functions. In the last class, we have already saw about the transform of the different types of the functions. At the same time, we saw about shifting rule, damping rule, everything. Now we are going to see about Z transform of the standard functions. Z transform of n square and n cube, and Z transform of cos n theta and sin n theta. Now you know that Z transform of n power k. Just now we saw the rule in the last video. Minus z into d by dz of z transform n power k minus 1. Now z transform of n. That means the k becomes 1 now, which is minus z into d by dz of z transform of what is that n power k is equals to n power 0. You know that anything power 0 becomes 1. That's why z transform of 1. Z transform of 1, we are already saw that this becomes z by z minus 1. Applying what is that the differentiation concept by using the quotient rule, v square v into u dash minus u into v dash will get a z minus 1 minus z plus z minus z cancel, will get z by z minus 1 the whole square. Similarly, if we substitute k is equals to 2, we'll get z transform of n square. We got the same formula. If we apply, we'll get z trans minus z into d by dz of z transform of n power 1. N power 1, we already got it z by z minus 1. The whole square, we just substitute over there here. Now from this, what we got for this means here, again we are going to differentiate by applying the quotient rule. We'll get v square z minus 1 whole power 4 b z minus 1 whole square into u dash z becomes 1 minus u into what you get here now v dash 2 into z minus 1. Again simplifying z minus 1 and z minus whole power 4 goes to cancel. The denominator becomes the whole cube. We'll get z square plus z divided by z minus 1 the whole cube. Similarly, while substituting z k is equals to 3, we'll get z transform of n square. We got, again we differentiate and simplifying, we'll get what is that here minus z into minus of z square minus 4z minus 1 by z minus 1 whole power 4. Finally, we got it z cube plus 4z square plus z divided by z minus 1 whole power 4. That's what we wanted to say is just apply the rule, and also we are going to apply what is that here the quotient. Very simple concept now. Now this concept, what is that here, which is nothing but the application of, we are going to apply for the damping rule over here, k power n into n, k power n to n square, k power n to n. What is the k power n to n says? Substitute z is equals to z by k. Okay, if you multiply by k power, you get z is equal to z by k. If you substitute over that here, what is that here? K z divided by z minus k whole square, k power n to n square become k z square plus k square z divided by z minus k whole cube. K power n to n cube becomes k z cube plus 4 k square z square plus k cube z divided by z minus k. What is that here? Whole cube. How can you find out now? Now you know that by help of the damping rule, k power n to u suffix n is equals to u power of z by k. Now multiply this k power n into n becomes substitute z is equal to z by k over that here. If you substitute it, that k square and k will be cancelled with k z divided by z minus k whole square. Similarly, z transform of n square, we got z square plus z divided by z minus 1 the whole cube. Again substitute z is equal to z by k over here. Now the whole cube and the square becomes cancelled. We get k z square plus k square z divided by z minus k the whole cube. The same thing will be applicable for as k power n z transform k power n to n cube also. Now z transform of cos n theta and sin n theta. How can you find out for the z transform for the functions? Very easy concept. The z transform of cos n theta. How can you find out means, we know that exponential form of a complex number e power I theta becomes cos theta plus I sin theta, e power minus I theta becomes cos theta minus I sin theta. Adding we got 2 cos theta, subtracting we got 2 I sin theta. Now from this, e power I n theta is equal to cos n theta plus I sin n theta. Z transform k power n becomes z by z minus k. Just so we are already known about that. Now e power I n theta, we write it as e power I theta whole power here. Substitute what is the k value here, e power I theta. Substitute over here. Denominator having the complex number. What we will do? We are going to apply for the, what is that here? We are going to apply for the inverse quadrant. This is called as the rationalized solution of the complex number. Z minus e power minus I theta divided by e power minus I theta. Now multiply, we got z square minus, if we take it as z into e power I theta plus e power minus I theta plus 1 z into z minus cos minus I sin divided by z square minus 2 the cos theta plus 1. And simplifying and also equating real and imaginary parts, we got z transform cos theta is equal to z into z minus cos divided by z square minus 2z cos plus 1. Z transform sin n theta is equal to z sin theta divided by z square minus 2z cos theta plus 1. Similarly, the same will be applicable for z transform of k power into cos theta, k power into sin n theta. Just substitute z is equal to z by k. That's it. Everything will be same. We'll get z into z minus k cos divided by z square minus 2 kz cos theta plus k square And also z transpose k upon sin n theta becomes kz sin n theta divided by z square minus 2 kz cos theta plus k square. Okay, just what is the concept means? We are just applying cos n theta. We take k power n by applying the damping rule, k power n into u sub x u bar of z by k. Wherever z will be the z by k, just to substitute it as, and k square will be cancelled. We'll got the same concept like this. Okay, now we got the Z transform of some standard functions. You see that Z transform of 1, n cube, k power into n square, everything is sorted. Cos n theta, k power n cos n theta, k power n, and n square, k power n into n, everything. Okay, sir. Next, we are more going to solve about find the Z transform of some following functions n plus 1 whole square. And these are all the concepts. Very easy concepts. Z transform n plus 1 whole square means apply the a plus b whole square formula. N square plus 2n plus 1. Apply Z transform separately. Z transform of n square, n, and Z transform of z by z minus 1. Now, the LCM term you take it at LCM z minus 1 the whole cube. Simplifying the z minus 1 whole cube means z square plus z. Here, z minus 1 whole square means z minus 1. On simplifying, we got the answers for this. Z square into z plus 1 divided by z minus 1 the whole. These are very easy problems. Easily we can solve it by help of our concept. Here, this 3n minus 4. Everything very simple. 4 sine into n pi by 4 plus 5a. Take the Z transform separate function. This is Z transform of sin n theta. Apply, we got the results for this. Okay. Now e power an. Everything is the same concept. No need of going more about this. Now the Z transform of cos n h n theta and the sin h n theta and the cos h n pi by 2 plus theta. First, you will see our Z transform of these two. This is called a hyperbolic function. We know that cos h n theta becomes e power n theta plus e power minus n theta divided by 2. And from that, this becomes e power theta whole power n, e power minus theta whole power n. Z transform of this in the form of k power n, z by z minus k, z by z minus k. Z will be taken as outside. Take at the LCM. Now e power theta plus e power minus n theta becomes 2 cos h theta. That's why we got a 2 z into z minus cos h theta divided by z square minus 2z cos h theta plus 1. The same will be applicable for sin h theta also. This, in between that, we are applying the minus sign. We are not doing more for this. Okay, so, yes. Now, from that, we just move on to what is that here. What is that here? Initial and the final value theorems. You see that these are the two basic theorems that will be applicable for the future. Okay, what is initial value theorem and what is what's that here? Final value theorem. If z transform of u1 is equals to u bar of z, then limit z tends to infinity u bar of z becomes u naught. That means take the u bar of z, nothing but z transform of u1 is apply limit z tends to infinity. Okay, z transform of u1 is there, sigma u1 z power minus by the definition of the z transform. Now which becomes u naught u1 by z plus u2 by z square u3 by z cube. Limit z tends to infinity. If we apply over there, here we'll get 1 by infinity becomes 0. That's why we got u naught only we got. That's what we are going to do for this initial value theorem for this. By help of that, we are going to see for the final value theorem the same thing. The more advanced of the initial value theorem, if z transform of u1 is equals to u bar of z, then limit z tends to 1, z minus 1 into u bar of z is equals to limit n tends to infinity into un. Take this the two different types of the formula just as we saw from that initial final value theorem. Z transform of un plus 1, z transform of u, which is z into u bar of z minus u naught, which is u bar of z. Now just subtracting, left hand side subtracting, right hand side subtracting. Take z transform of outside. Here u bar of z is common, we'll get z minus 1 into u bar of z minus z into u naught. And also what we got now from this, z transform of un plus 1 minus un becomes as usual, sigma un into z power minus 1. Here also z minus 1 into 6. That's what the concept says. After you got z minus 1 into u bar of z, take limit z tends to 1. If you take the limit z tends to 1, limit z tends to 1 here, here also limit z tends to 1 here. Now this term is as usual. Now limit z tends to 1 means this point becomes what we got now 1. We'll get 1 into u naught, which becomes 1 power n. Limit z tends to 1, z minus 1 into u bar of z becomes this u naught comes to left hand side, so that we'll get u naught plus we got it. Okay, this is what we got now. This is what we got now. U naught plus limit sigma n is from 0 to infinity un plus 1 minus un. I'm choosing the limit m tends to infinity over here, the new concept for this. Limit m tends to infinity, if I apply here, just substitute n is equal to 0, u1 minus u naught, u2 minus u1, u3 minus u2. Like the concepts we got. Limit m tends to infinity minus u naught plus u1 plus, because all the terms are going to cancel now here for this. What are the terms are going to cancel now for this? The maximum all the terms are going to, what is that here, u1, here u1 you see, this is except this u naught and the un plus, so all the terms are going to cancel if you go see for this. Okay, now so that we got what is that here un plus 1, I just substitute m tends to infinity means m plus 1 is also tends to infinity. That's why this m plus y2 is just n. Limit n tends to infinity, u when I got. That's what I got the proof of what is that here, initial and final value. Yes.